right, now we're going to work out 2018 AB free response, number 6. I'm going to focus my camera there. There we go. And I was going to make sure I had it open here to the left so you can see it. All right, now I printed a copy of this out so that we could draw on it, because part A says, consider the differential equation dx dt equals 1/3 x times y minus 2 quantity squared. And part A says the slope field for the given differential equation is shown below. Sketch the solution curve that passes through the point 0, 2, and sketch the solution curve that passes through the point 1, 0. So 0, 2 is this point right here. And if we follow the slopes there, it looks like this might be an isocline, and so this would be my solution that passes through 0, 2. Okay, so that's the first one. The second one passes through the point 1, 0. There we go. And if I follow the slopes this way, it looks like it might look like that. And then if I follow the slopes this way, it might look something like this. And you don't have to be precise. You just kind of have to follow the flow of the slopes. And if it looks reasonable, that's okay. All right. So there you go. Next part says, let f be the particular solution to the given differential equation with the initial condition f of 1 equals 0. Write the equation of the line tangent to the graph at f of x at x equals 1. Use your equation to approximate f of 0.7. Okay, so for part B, what do I need to find the equation of a tangent line? Well, I need a point. And what is the point? Well, they gave us f of 1 equals 0. So there's my point. And I need a slope. So I need f prime of 1. And they gave us dy dx is equal to 1/3 x times y minus 2 quantity squared. And so I'm going to go such that x equals 1 and y equals 0, because that's the point I need to slope at. So what happens when I plug in the points here? We get 1/3, x is 1, which is nice, and y is 0. So that's going to be -2 quantity squared, which makes this 4. So my slope is 4/3. So the equation of the tangent line at 1, 0 is y minus 0 equals 4/3 times the x minus 1. So there's my equation of the tangent line. And now I want to use that equation of the tangent line to approximate f of 0.7. So I'm going to say that f of x is approximately 4/3 x minus 1. And I'd add the 0 to the right here, but adding 0 is, pointless. So I'm going to say f of 0.7 is approximately 4/3 times 0.7 minus 1, which is 4/3. And this is going to be -3/10, right? Because it's -0.3, which is equal to -4/10, which is equal to -0.400. Okay, so that would be my approximation for f of 0.7. And you could have left your answer just like this or this, but if you have a decimal, you should have how many decimal places? 3. All right, so part B wasn't too bad. Let's look at what part C says. Part C says, find the particular solution to the, y equals f of x to the given differential equation with the initial condition f of 1 equals 0. So again, they're telling us that f of 1 is equal to 0. And our differential equation is dy dx is equal to 1/3 x times y minus 2 quantity squared. And to solve a differential equation, we have to use the method of separation of variables. So I'm going to take the y expression and divide. So it would be dy over y minus 2 quantity squared equals 1/3 x and multiply by dx. Bringing out my magic integral marker to integrate both sides, I'm going to rewrite this as y minus 2 to the negative 2 dy equals, and now this is going to be x squared over 2 times 1/3, so this will be x squared over 6 plus c. Now, I could use u substitution here. We could say let u equal y minus 2. Whoops, I'm sorry, I left the u out. And du is dy. And then when we integrate, we get u to the minus 2 du, which is equal to u to the minus 1 divided by minus 1, which is plus c right here. But we don't need the plus c when we are doing this because I've already added the c over here. So what does this turn out to be? This turns out to be negative 1 over u. Okay, well, so then this will be negative 1 over y minus 2 equals x squared over 6 plus c. Okay, now I've got to solve for y. So the first thing I'm going to do is multiply by a negative. So I get 1 over y minus 2 equals negative x squared over 6 plus c. If I multiply a negative 1 times a constant, is it still a constant? The answer is yes. And then now you have to flip. If you're going to flip this side, you have to flip the other side. So if I make this y minus 2, I have to flip the entire other side. So this would be negative x squared over 6 plus c to be equivalent. Okay? And then I can add 2 over. So we get y equals 1 over negative x squared over 6 plus c plus 2. All right. Now, to solve for my particular solution, I'm going to be using my point that they gave us, which is using 1, 0. That means y0 equals 1 over negative 1/6 plus c plus 2. And now I'm going to take my paper and bring it this direction here so you can follow along. I'm going to bring the 2 over, so we get negative 2 equals 1 over negative 1/6 plus c. Cross multiplying, I get negative 2 times negative 1/6. Sorry, got a little crazy with my parentheses here. I meant to be negative 2 times negative 1/6 plus c equals 1. All right, and I'm going to move the, so this would be 1/3 minus 2c equals 1. Now you might ask, why am I multiplying this by a negative 2 here? Because I need to solve for this c, and that 2 is important here. Okay, because this c doesn't have a 2 multiplied by it. Okay, so let's see if I multiply the right. That's negative 1, negative 1 third. 2 negatives make a positive, and then I have a negative of 2c. So we get negative 2c equals 1 minus 1/3 is 2/3. And so c is going to equal negative 1/3. Okay, so let's plug that in to my final equation. We get y equals 1 over negative x squared over 6 minus 1/3. Now I'm going to multiply everything by, this is plus 2 out here on the outside. Yeah, I want to get rid of this fraction thing here. So I'm going to multiply by 6 over 6, right? This expression alone, 6 over 6. And I'm going to get y equals then I'm going to bring the negative up top. So negative 6 over, and this would just be x squared plus, because I got rid of the negative, 6 times a third 2 plus 2. So this here would be my solution to my differential equation. Now, on the AP exam, I believe that this expression right here above it would be just fine if you left it like that without doing this. But, I was uncomfortable with the double-decker fractions. Okay, so let's go over what points are. Well, lucky for us, we get 2 points for this situation. We get a point for drawing the line through the point 0,2, and we get a point for the particular solution that we drew through the point 1, 0. So that's 2 out of 9. That's good news. For part B, this is worth 2 points. I wish it was worth 3 because it was a little bit more work needed. But you get 1 point for coming up with the equation of the tangent line right here. And then you get 1 point for your approximation. All right, so the tricky part here is that you need to write f of 0.7 is approximately with the squiggle, because we're approximating here, and have 2 decimal places if you're going to use a decimal. All right, so now for part C, which is worth 5 points. So on the AP exam, if you can't do A and B, but you can do C, that might be 5 out of 9 points. So never give up. All right, so you get a point for separating your variables. So if you go from this step to this step before we put the red, magic integral marker in here, you get a point. You get 2 points for the antiderivatives. They were kind enough to give you a point for this antiderivative and a point for this antiderivative. Okay? Then you get a constant of integration and initial condition point. So if you get a cupcake or a plus C and you use 1, 0, you get a point. And then you get a point for your final solution. So that's 5 points on this problem, which is very cool. So I know that differential equation problems are nice, point-rich problems that you guys can get a lot of points on. So have a good day and on to the next one.